Every time you open a notebook, you expect a quiet, pristine space for your thoughts. But the process that builds that blank page starts at a scale invisible to the naked eye. As this diamond-tipped needle pierces the stack, it parts the individual paper fibers with microscopic precision. If the needle is misaligned by even half a millimeter, the fibers tear instead of separating, weakening the sheet at the exact point where the binding must eventually hold the most weight. That needle is the final, surgical touch in a journey that begins in a different environment, one defined by extreme heat, by multi-ton pressure, and violent industrial chaos. Step onto the floor of a modern megafactory, and you won't see anything resembling stationery. The environment is loud, heavy, and intensely industrial. The true origin of your paper is inside these massive vats, where a thick, fibrous wood pulp slurry is churned continuously. At this stage, the material is a heavy, untamed liquid. It holds no structure and offers no hint of the crisp pages to come. To force this mixture into a usable form, the slurry is fed directly into a series of solid steel rollers weighing several tons each. The rollers crush the slurry, instantly squeezing out excess water and compressing the erratic mix of fibers into a dense, flat sheet. From there, the compressed sheet is hit with extreme heat. Moisture vaporizes instantly, sending thick bursts of steam billowing across the production line. As the moisture escapes, the fibers lock together, pulling that wet liquid mess into a continuous, miles-long web of solid paper. Forging the foundational skeleton of a notebook requires this specific gauntlet. Only by surviving this extreme pressure and boiling heat can the raw pulp be transformed into a unified, physical web. Once the paper web is formed, the environment shifts. The steam clears, replaced by the clinical, high-intensity lighting of a precision engineering lab. The paper web is now moving at highway speeds, threading its way through dozens of heated stainless steel drying rollers. This diagram illustrates the core challenge: tension control, mapping opposing mechanical forces on the web. It's fragile. If rollers fall out of sync by a millimeter, vector forces collapse, tension spikes, and the paper shatters, halting the factory. Assuming the tension holds, the web reaches the final compression stage. Here, highly polished cylinders aggressively iron out the microscopic texture of the paper, creating a surface smooth enough to accept ink without feathering. The result is a sheet of total, unyielding flatness. Achieving this requires the machines to hold thousands of pounds of pressure in a state of constant microscopic balance across the entire line. With the paper cured and smoothed, the continuous web has to be divided. It is folded and stacked into distinct sections called signatures, ready to be severed from the main line. A laser-guided robotic saw drops down, slicing cleanly through hundreds of these stacked pages in a single, synchronized motion. The lasers ensure the cut is absolute. There is no fraying and no paper dust, just a sharp edge where every single page aligns flush with the next. Those aligned pages then enter the binding station. This is the most delicate mechanical sequence in the entire facility. Microscopic nozzles fire sequentially, applying perfectly measured droplets of translucent adhesive directly onto the exposed texture of the paper spine. Fractions of a second later, a heavy mechanical press slams a rigid cardboard cover onto that wet spine, locking the adhesive and the paper together under tons of downward pressure. If there is too much glue, the book won't open. Too little, the pages fall out. This specific choreography of micro-adhesives and extreme compression creates a spine that sits perfectly flat on a desk, without snapping. Surviving the assembly line is only the first phase. Finished notebooks are continuously pulled at random for a rigorous quality control gauntlet. First, a pneumatic actuator clamps down on the spine, rapidly whipping the covers open and closed thousands of times in a matter of seconds to simulate many years of heavy wear. Next is the optical alignment check. This laser map visualizes the final cut's geometry, defining strict sub-millimeter tolerance zones. If a single page corner strays outside that mathematical boundary, the system instantly halts, rejecting the entire batch. Only the notebooks that clear these sensors move forward. They are verified to withstand years of repetitive stress without the spine cracking or a single page drifting out of alignment. Back on the main line, the final assembly is a blur of motion. Synchronized robotic arms operate at speeds that the human eye can barely track. Vacuum suction cups dart down, instantly gripping, orienting, and stacking the finished notebooks into dense, perfectly aligned blocks. High-heat machines wrap these blocks tightly in thin plastic, applying a final layer of pressure to create a locked, moisture-free environment for shipping. When you step back and look at the entire floor, the true scale of the operation comes into focus. This facility spans the size of multiple football fields, all dedicated to a single product. Thousands of identical notebooks glide continuously along multi-tiered conveyor belts, forming endless geometric grids that stretch out toward the shipping bays. The miles of volatile, wet slurry from the beginning of the line have been fully processed into solid, pressurized units, ready for the final leg of their journey. Ultimately, all of that industrial power serves a single human user. On the floor, master technicians still inspect individual units by hand. They test the paper with heavy fountain pens, watching as the nib glides smoothly across the surface. The ink sits perfectly crisp, with zero feathering or bleed-through. That quiet, reliable utility is the entire objective. Every clean line and perfect fold is a direct result of the violent, highly engineered gauntlet that built it.